Hello everyone, I am back. I know it's been a while since we've had our last video series. Today we're going to talk about the relationship between multiplication and division, using the open array to make the connection. We've been spending a lot of time on multiplication and division work in our classroom, so I wanted to post a video to help not only the students but the parents to see how we're using the array and our knowledge of multiplication to solve division problems. On the side here, I have some big ideas. We're going to talk about the distributive property. We're going to talk about the associative property, which deals with using your 10 facts, so that's why I have 10 as your friend. And then in division, there's grouping and sharing division, and helping us understand the difference will help your children understand the concept of division. So in multiplication, it's very important that you learn your basic facts. So in our classroom, we spend a lot of time memorizing our facts from 1 times 1 up to 12 times 12. And the reason we're doing so is so that we can solve problems like this, 14 times 7. So in the old days, when I went to school, or when some of your parents went to school, we learned what's called the standard algorithm. So what you would do is you would take your ones place and multiply it by your ones, and you would get, okay, for this one, 7 times 4, that's 28. And that 2, you would put in the tens place because that's 28. And then you would multiply your ones times your tens, that's 7 times 1, that's 7 plus 2, that's 98. Okay, once you're done, you would cross out the ones, and now you multiply your tens times your ones. So that's 40, or 4, but you have to put your placeholder. And they always told us there was like a magic 0 or your imaginary 0. And never really understood why that was there, but we just knew to put it there. And then we multiply our tens times our 10, which is 100, and that will go here. And then you would add these are called partial products. All right, and once you add up the partial products, you would get an answer of 238. Now, the algorithm is nice because it's fast, it's easy to use, it's simple. But when you're learning multiplication and you're studying place value, I want you to also understand that these digits have a value. So 14 is really 10 and 4 more. And 17 is 10 and 7 more. So if I draw an open array, which is a rectangular, it's rectangular, and I think of 14 as 10 and 4 and 17 as 10 and 7, I can split my array into pieces. And each piece represents the value of these digits. Let me give you an example. So this is 14 rows or 14 columns of 17, or 17 rows of 14. When I split it into my parts, each part has its own dimension. So this is 10 by 10. Well, 10 by 10, that's 100. And this is 10 by 4. Well, 10 times 4 is 40. And this is 7 times 10, because this side is 10. So the opposite sides of a rectangle are equal. So 7 times 10 is 70. And this is 7 times 4. And that's 28. And what I've taught my students is combine the top two parts. That's 140. And I combine that, and that's 98. And look what we have here. 98 and 140. Same thing you would get if you use a standard algorithm. The difference is when you think of the array, you use the array to model your thinking. It helps you understand that multiplication is about groups, and that 1 is really 10, not 1. So you don't lose the value. This is also the distributive property. because what you're doing is you're splitting the array into two parts, and these factors are shared. So it's 10 times 10 and 10 times 4. And this is 7 times 10 and 7 times 4. So you can hear the two factors that are shared. Or you could think of it this way. 10 times 10, and then you have 4 times 10. So the 10 is being shared. And then 10 times 7 and 4 times 7. So the 7 is being shared. So this is just one example of how we use the open array to model multiplication. All right, so part 2 is coming up. In part 2, we'll talk about the relationship between multiplication and division. See you soon.